Welcome back to the next session of motion in a straight line chapter. Friends, in the previous video I dealt with the position time graphs. In this year those topic or those graphs were deleted. But today, to understand the next topic, that is velocity time graphs, we must need the help of those graphs, that is position time graph. If the body is rest, what happens? If the body moves with a uniform velocity, since I am using the word velocity here, so topic is velocity, I am continuously using the word velocity only, because in the previous video, in the previous topic it was position, so I was using position. So now today it's velocity, I am using the word velocity. Now, if the body is rest, what is the nature of graph? If the body moves with a uniform velocity, what is the nature of graph? If the body moves with some initial velocity, then moves with a uniform velocity. What is the meaning of that? I will explain afterwards. And third one is, if the body moves with a decreasing uniform velocity, having some uniform velocity or initial velocity, what happens? What is the nature of graph? Then, if the velocity of the object changes irrelevantly, that is not depending on the time, so that is an increasing acceleration, decreasing acceleration, or if I throw an object to upward, then it will come back to the downward. That means what? Then there is an acceleration in the upward direction. As the height increases, the velocity or the speed of the object decreases. At a certain position it reaches 0, then it will come back. While coming back, its speed increases under the influence of gravity. What is the nature of graph? So those 6 graphs I am going to deal today. So let us start one by one. So now, since the velocity changing with respect to time, hence the velocity is taken along y-axis and the time is taken along x-axis as we did yesterday. So in the first graph, so what I will do, I will take the time along x-axis and the velocity along y-axis. Only one time I am writing this detail. So every time it is understood that along y-axis velocity is there, along x-axis time interval will be there. Now, if the body is at rest, then there is no acceleration at all, because if velocity is 0, then rest means it is not at all moving. So hence there is no graph at all. So I can say here the body is at rest, but actually I am not doing that one. So let us say, let us start one by one. If the body moves with the uniform velocity, having some initial velocity, right? So let us start one by one. So now look at this. Here at time t equal to 0, the body already having some speed. After it coming to this position, it attains uniform speed or uniform velocity. Then it moves after this interval. Then the body goes like this. So it is called referred as uniform velocity or uniform acceleration. It is uniform acceleration. Now, in the second graph, speed is taken along x-axis, velocity is taken along y-axis. Now, in this, again at the origin, at time t equal to 0, the speed or the velocity of the object is 0. Hence, it is here. Because V is 0, T is both are here. After this, the body moves or the object moves or the particle moves with a uniform velocity. That means what? As the time increases, velocity also increases. Then it goes like this, straight line. This graph plays very, very important role in our further explanation. So now, with help of this one, I will take another kind of graph. Same graph, but with some little bit different meaning. So let's take again, this is what? Time period along x-axis, then it is velocity along y-axis. Now, as I said, already body moves certain distance having some speed. Let us say the velocity of the object at a time t equal to 0 is here, this much. After coming to this point y-axis, this is called as initial velocity. Very important. So this speed is called as what? Initial velocity. Though time is 0, the value is possessing some velocity, and that velocity is called as initial velocity. After reaching this point, then body moves with a uniform speed. So this is called as another Milli graph. That means what? This is what? Increasing velocity, increasing acceleration, increasing acceleration when time t is equal to 0. This is also increasing acceleration, but at time t, v is not equal to 0. But here it is what? T equal to 0 as well as v equal to 0. But here v is not equal to 0. So it has some initial velocity at this position. So now it increases the acceleration or the speed. So this will give the another nature of graph. Now, if the body moves with a variable acceleration, then it goes like this. It is of a random shape. Next, if the body moves with having some initial velocity but decreasing, it is increasing or it is decreasing. So then the body will go like this. This will be the nature of the graph. Next one, if the body moves with increasing acceleration means what? It is depending on the time, but it is not uniform. So the non-uniform acceleration. So it goes like this. Increasing acceleration. Then even I can draw this graph 7. How it is? Then again velocity is taken along y-axis, time is taken along x-axis. Then decreasing velocity. So if it is like this, then it goes like this. Decrease. It has some velocity and showing some declination, or else like this. It is also decreasing nature. Then even you can draw a point. So how it will be like this? See. This is time, this is velocity. Now, if I throw an object upward, it will come back. So as I say, when it reaches some velocity, so this is the initial velocity. If I throw, it will come back. It will come back with certain retardation, they call negative acceleration. So this is what the body is thrown upward and coming downward. So this is upward and coming downward. So it shows some negative acceleration. So that is called as what? Retardation. So in this way we can create our own different cases of speed or velocity with respect to time and draw the graphs. So here I have hardly 8 graphs. So here you can draw 2 or 3 more graphs, or see in your textbook only they explain hardly 4 graphs, but here I explained 8 graphs. So I think it is sufficient to you people. So now, using this velocity, what is the necessity of studying this velocity time graph? First and foremost, we have to study that concept. That is, what is the importance or what is the necessity to study these graphs, right? To study motion in a straight line. Here is the answer. Friends, to understand certain concepts of physics of our daily life, as I said, physics is what? It is somehow related to our life itself. If we are a moving object and if you are moving from one place to another place, let's say assume that I am being in a straight line. So now what are the different types of situations we may face in our day-to-day life? So to understand this concept, so first and foremost we have to understand the velocity time graph, that is acceleration thing. And second thing is, so whatever the graphs I have drawn here, so here area under the curve will give the displacement of the object at that instant of time. First thing. Second thing is, if I draw the slope or if I calculate the slope will give the acceleration of the object at that time. So now how to draw the slope, how to get the slope, everything I will explain now step by step. To understand these mathematical concepts, so mathematical language should be used to understand the physical or physics phenomenon. So now here mathematics is acting as a tool or a language to understand the concepts of physics, especially the motion in a straight line. Here now, friends, I am converting the physical phenomenon or physics phenomenon into using mathematical expression or talking in mathematical language. So for this, I had to start with a new topic called as kinematic equations. So very important topic, that is kinematic equations. Kinematic equations. So there are two methods to calculate the kinematic equations. Now in this syllabi, in your syllabi, I will given only the graphical method. So I will start with the graphical methods. So graphical method, there are three important fundamental equations we are going to study in this topic. Let us start one by one. So now the first relation itself goes like this. And one more thing, friends, to derive the three equations, we are using only one graph. That is the beauty of physics. So now only one graph giving three different physics or equations. Already you know, you are studied in the 9th standard in our motion chapter. So now today I am going to introduce the mathematical steps in order to derive those equations. Let us start one by one. So now we are assuming that a body is moving along x-axis, so along y-axis, or having some initial velocity, say v. So here I have taken the time period. So this is indicating time. I can write just a t. So now here I will take a velocity. And v. Now here I have to consider the initial velocity of the object. At time t is equal to 0, at time t equal to 0, body possesses some initial velocity, say a. So once it possesses the initial velocity v or initial velocity at the position a along the y-axis. Now if it is moving with a uniform speed or uniform velocity, it goes like this. So it reaches the point B. It reaches the point B. Couple of minutes back, I said that area under the curve will give the displacement of the object. That means I can calculate the value of x or x naught or s, which is used in your textbook. Some books use s, some books use x naught, and some books use x. I will use whatever. I will use only one concept, that is x naught. And second thing is, as I said, the slope will give the what? The slope will give the acceleration of the object in that time period. So now let us draw how to calculate the slope. So to calculate the slope, first and foremost, always keep it in the mind. Slope means always y-axis divided by x-axis. This is y-axis, this is x-axis. So then I have to calculate what is the value of x-axis and y-axis. Then y-axis divided by x-axis will be the slope of the object. So now let's transform certain things into our convenience. So now here I am writing certain things. Let's start one by one. Let u be the u is equal to OA is equal to initial velocity. This is very important. So here I am using the word u. In some textbooks they use v naught. So v naught is also same, or u is also same. So let u v naught or u is equal to OA is equal to initial velocity. Then after some time t, right? Here only I am right. After time t, the final velocity. I will draw the final velocity here. Look at this. So now it reaches, B, C, and D. C I will take afterwards. D. BD will give the final velocity. So now here I will write here. So capital small v is equal to BD is equal to final velocity. Three things are involved here. Initial velocity V0, final velocity V, and time period T. Now, friends, what I said here a couple of minutes back, area under the curve will give the displacement, slope will give the what? Slope will give the what? The acceleration. So I want to calculate slope. Slope will give the acceleration. How to calculate slope? Slope is equal to y-axis divided by x-axis. This is a fundamental equation always. To calculate the slope, y-axis divided by x-axis. I will write a as this. So in the y-axis, I will make certain things. I will draw a parallel line to the final velocity. Final velocity. Look at this now. So it is now reaching the point C. BC is the y-axis, AC is the x-axis. So now, in mathematical expression I can write here, BC by AC will give the acceleration when the body moves with the uniform speed or uniform velocity or uniform acceleration. Now, since OD is a time period T, so that is equal to T equal to OD, I can write here T equal to OD. If T is equal to OD, then AC is parallel to OD, so I can write here AC is also nothing but T. But how to calculate the value of V? That's one more thing. As I said, U is the initial velocity of the object, so this becomes U. OA is equal to U. If OA is U, OA is parallel to CD, so this also becomes what? U. Then here I wrote one more thing. V is equal to VD, that is final velocity. So this distance is there now. So this distance itself is called as what? V, final velocity. So I know VD, I know CD. Then how to calculate BC? So now I will write here for our understanding purpose. So BC is equal to BD minus CD divided by AC as is. A as is. BD. What is BD here? BD is nothing but what? V. Capital small v. Capital small v minus. What is CD here? CD is U. So U divided by. What is AC? AC is T. T. Just rewrite the expression. So now take 8T this side. This becomes AT is equal to V minus U. I can write this equation as V minus U is equal to AD or V is equal to U plus AD, because minus sign if I take that side it becomes a plus. So V is equal to plus U plus AD. This is one more very important fundamental equation to calculate the final velocity or initial velocity or acceleration or time interval or time taken by the object to travel that much of a distance or the displacement. So this is very fundamental equation, that is V equal to U plus AT, or according to your convenience, if I take one more step, only same method. So if I rearrange the same equation, that is A is equal to BC by AC, that is equal to BD by BD minus CD divided by AC. So A is equal to, so V is the first thing, and here in some textbook they use, instead of in the place of V they use V0. So let me use V0 only. So V minus V0 divided by T. Take this side, becomes AT is equal to V minus V0. So that is V minus V0 is equal to AT. So let me rearrange the graph, that is equal to V equal to V0 plus AT. This is one more parallel equation. Same parallel equation. Here I use initial velocity as U. Here I use initial velocity as V0, because time is t equal to 0 here. So that is why V0 I use here. V0 indicates initial velocity, V indicates final velocity, V indicates acceleration, T equal to time period. Friends, henceforth we are now eligible to solve the numerical problems of our day-to-day life. First, to understand the fundamental concept of this equation, so let me start certain things here. So all the concepts we have here, V we have, V0 we have, A we have, Total 4 terms are there. 1, 2, 3, 4 terms are there. So now, if they ask, calculate the final velocity of a car having some initial velocity or acceleration and time period. If they give acceleration, time period and initial velocity, then it is possible to calculate 3. So that means what? If they ask any one term, they must give the remaining 3 terms. They may hide any one or they may ask any one, and by giving the 3 known values. Right? It may be in a direct way or it may be in a twisted way. So now, this is the first fundamental equation where we are going to calculate our physics problem. So this is V equal to V0 plus AT. So this is, and this part is there in the syllabi. This is another part only for understanding purpose. I explain this method also. Friends, in the next class, the remaining two things, that is the area under the curve will give what I said, the displacement of the object and the relation between the velocity and the displacement with respect to acceleration and initial velocity. That 2 equations I am going to derive in the next class. Thank you.